Yeah, yes. So once again I quickly repeat here what my task is. Today I will show that how from this formula, from our original conditions, that is from the formula of sin inverse x plus sin inverse y is equal to this thing, under these very restrictions, how we are going to obtain the values of sin inverse x minus sin inverse y and what will be their eventual conditions. So now see what you need to do here. Simply at place of y, you are replacing y with minus y throughout in this equation. So this will fetch you this particular equation. So here see it's fine because here see there was hardly any condition. X and y could be anything provided xy is less than 0 or xy is greater than 0 and x square plus y square is greater than 1. So here I am putting this thing. Now see what actually happens. Here this thing, this implies what? Sin inverse x plus and this plus with this minus, because sin inverse minus y is minus sin inverse y, so I will make it minus sin inverse y is equal to sin inverse, please see, x, here it will be x under root 1 minus y square, and because minus y square and this minus will make it this thing and this is this thing. So here it is this thing, and please see x minus y is less than 0. Let me multiply with this thing. So with minus sign, so what I will get? X into y, it is less, instead of less than 0, it will become greater than 0. It will become greater than 0. So see here, this is the formula, this is the condition, one condition. If x minus y is less than 0, then sin inverse x minus sin inverse y will automatically be equal to this thing. Sin inverse x 1 minus y square minus y 1 minus y square x y greater than 0. Because now see, this equation and this equation, they are the same equation. So this is the formula how you will derive for sin inverse x minus sin inverse y. For second condition, what will be the appropriate change? Here x minus y is greater than 0. So obviously this will fetch you what? Multiplying with minus y. So what it will give me? X y is less than 0. X y is less than 0. And what else? And here this equation will remain same. X square plus y square is less than 1. So for this formula to hold, and this is nothing but factually this thing you have obtained from this one. So here see, and this is the formula. See, it is not a, here, this is giving you the formula for sin inverse x minus sin inverse y under these conditions. Under, see, in the original it was xy is less than 0. Or xy here, if it was greater than 0, then also x square plus y square ought to be less than 1. So here, these changes will accrue here. So please take it that this is how we will find the formulas for other. In the original equations, likewise for other, what is the second part? Pi minus sin inverse, this whole lot, isn't it? And under what are the condition? You have seen that if xy is greater than 0 or x is greater than 0, y is greater than 0 and x square plus y square, this should be greater than 1. So now see here, for obtaining, again you do the same thing. Replace y with minus y. So here you will get sin inverse x minus sin inverse y. And here what you will get? Pi minus sin inverse. Here it will remain same. Here you will get minus sign. At place of this plus you will get minus sign. And what will be the condition here? X will remain greater than 0. Y greater than 0 will become what? Now you will write minus y greater than 0. So y will be less than 0. Eventually see, y will be less than 0. See, let me do it again. Otherwise you will get confused. First part we have already done. Second part, see. I am doing the see, second part. You know very well that sin inverse x plus sin inverse y is equal to sin inverse, pi minus. It is pi minus. Let me write pi minus. It is pi minus sin inverse, yes, x under root 1 minus y square plus y under root 1 minus x square under what condition? If x is greater than 0, y is greater than 0 and x square plus y square is greater than 1. Yes, this is the condition. Let me put it on my this vibrator mode. Today I forgot it. I got late here. Okay. Yes. Okay, I'm sorry I didn't kept it on vibrator mode and therefore there was a disturbance. Somebody called me. Okay, now see, this was the condition. Now see what you need to do. Here put y is equal to minus 1. Put y is equal to minus 1. So what do you get here? Sine inverse x plus sine inverse minus y is equal to pi minus sine inverse. Wheresoever y is coming, simply replace it with minus y whole square plus minus y under root 1 minus x square. And this here x is greater than 0. At place of y, minus y should be greater than 0 and x square plus minus y whole square should be greater than 1. This is exactly the same thing. Simply you have replaced here y with minus y. Now see what is to be done. Here see this thing becomes what? Sine inverse x plus sine inverse minus y, it will become minus sine inverse y is equal to pi minus sine inverse, and here see this thing becomes x under root 1 minus y square minus y under root 1 minus x square, and then see what this thing becomes. Here now x is greater than 0, minus y is greater than 0. If you this thing, this inequality, what you can write, multiply with this thing, so minus y, and x square plus y square is greater than 1. So see, that will be the requisite. Now this is what? This is the same thing. So this is the result of sine inverse x minus sine inverse y. This will be equal to this thing, and 1. When x is greater than 0, y is greater than 0 and x square plus y square is greater than 1. Is greater than 1. Okay, so this is how you will be obtaining all these things. So now see, this is how you can derive all the results for minus sign, basically from this thing. So now we stop. We have completed the entire theory and now we will take up the questions. Okay, open your exercise please. Today now we will take up all the questions today, and then we will start the new chapter. Okay, yes, let me see which exercise. Okay, first exercise, too simple. We can take 1-2 questions therein. Exercise 2.1 here. It's a very simple exercise. See, I said if you are very good in theory, then see you hardly need to do anything. Find the principal value of the following. Now suppose it is cos inverse root 3 by 2, cos inverse root 3 by 2. You have to find this is the question 2, isn't it? So very simple. Cos inverse root 3 by 2. What is root 3 by 2? It is cos pi by 3. So it is cos inverse cos of pi by 3. And see, please see, this is in the principal branch. What is the principal branch here? It is already in the principal branch, so I can very well write, and this is simple. It is nothing but pi by 3. So pi by 3 or pi by 6? cos 60. Yes, it is pi by 6. Please make it pi by 6. So that will be the answer. So simple thing. Tan inverse minus 1. Tan inverse minus 1. So what the thing is? See, tan inverse minus 1 is what? Tan inverse 1, and you know it is minus tan inverse 1 is what? Pi by 4. So that's the answer. So simple thing. Yeah, there is hardly anything difficult in it. Let me take a few other questions where. Okay, sec inverse 2 by root 3. Sec inverse 2 by root 3. You can take it, or let us take some few more difficult questions. Sec inverse, okay, 2 by root 3. Okay. Now, you know that sec inverse 1 by sec inverse x is equal to what? Cosec inverse sec changes into what? It's inverse cos. So it will be cos inverse 1 by x. So 1 by x will fetch you what? Root 3 by 2. And in the case of cos, again see what is the value of cos? Pi by 6. Cos 30 degree is root 3 by 2. So it is cos inverse, and at place of root 3 by 2, what you can write? Cos pi by 6, and eventually it will be pi by 6. So simple properties. See, these questions have been purposely given to acquaint you with the basic properties, and then you can do it this particular way. Let me take up another question here. Find the values of the following. This is your question 11. 11. Tan inverse 1. So simple. You have to write their values in the principal branches. Plus cos inverse minus 1 by 2. And what else? Plus sin inverse minus 1 by 2. Okay. So what you can do here? Please see. Tan inverse 1. Principal branch of tan inverse lies where? In. It is, see, the range lies between of this tan inverse, it will be from minus pi by 2 to plus pi by 2. So tan inverse n, you can safely write pi by 4 plus, just now, sin inverse minus pi by 2. Minus 1 by 2 is what? Minus pi by 6. Sin 30 degrees 1 by 2, so sin minus 30. So minus 30 is what? Minus pi by 6. So sin, it is sin minus pi by 6. So what you can write it is better you write minus pi by 6. Let us see this thing. Minus cos inverse minus 1 by 2. 1 by 2, where it will lie? Cos negative, it is between, see, it is cos of 60 and then cos pi minus pi by 6. Cos pi minus pi by 6. 6 pi minus what it is. Cos pi minus pi by 6, what it will be? It will be cos pi by 6, and it is in the second quadrant, and cos pi by 6 is what? Cos 30, so it is no, pi by 3. Cos pi by 6, cos 1 by 2. Yes, it is cos 60 degrees is 1. Cos 60 is 1 by 2. Minus, of course, you are getting. So cos 60 means pi by 3. Pi by 3 means it is what? Pi 3 pi minus pi 2 pi. It will be 2 pi by 3. 2 pi by 3. Yes. Cos 2 minus cos 2 pi by 3, and cos 2 pi by 3 pi minus, no, please, cos pi minus pi by 3, yes, it's okay, it is cos minus cos pi by 3, you want to write here cos inverse minus 1 by 2, at place of minus 1 by 2, what you can write here, cos pi minus, because what is the value of cos pi minus 3? It will be cos pi by 3 with negative sign, and this is minus 1 by 2. So fine it is. So what we are writing is, at place of minus 1 by 2, what we will write? Cos of pi minus pi by 3. So cos inverse at place here, what you can write? Pi minus pi by 3, which is effectively what? So it is cos inverse cos will give you pi minus pi by 3, that is 2 pi by 3. So what you will get? Pi by 4 plus 2 pi by 3 minus pi by 6. And this thing you can calculate. What it is? What is the LCM? LCM will be, yes, 6, 3, 12. Okay, 4, 3 pi plus 3, 4, 4 to 8, and minus 2 pi. Minus 2 pi. So it is 7 pi by 12. That's the answer. So this is how you can do it. So it's quite simple. There is hardly anything. Now let us come to your this set. Exercise 2.2. Let us try a few questions therein. Or should we try the miscellaneous? Bhavya sir? 2.2. Okay. Let us take these questions here of 2.2. Let us try a few questions therein. Okay. 2.2. Okay. Okay. First question is very simple. 3 sine inverse x is equal to sine inverse 3x minus 4x cube. So here you put x is equal to what? Sine theta. So left hand side will be 3 theta. Simple question. You can do it on your own. Okay. Let me take the fourth question here. Let me take the fourth question here. It is 2 tan inverse 1 by 2 plus tan inverse 1 by 7 is equal to tan inverse 31 upon 70. Okay, what is this 2 tan inverse 1 by 2? It is tan inverse, yes, 2x. See, 2 tan inverse x is what? Tangent, because you can write it, tan inverse 1 by 2, 1 by 2. So it is 2x, x is what? 1 by 2 upon 1 minus tan square x. X is what? 1 by 2. That's all. So 2 goes, so it is tan inverse 1 upon 1 minus tan inverse 1 by 2. So tan inverse, sorry, not it won't be tan inverse here, it will be simply tan inverse, sorry, let me write it afresh. Tan inverse of 2 tan inverse is nothing but tan inverse within bracket 2x. 2x upon 1 minus x square. X square is what? 1 upon 2 square, that is 1 upon 4. So this will be what? Tan inverse 2 goes 1 upon 1 minus 1, 3 by 4. So it is 3 by 1 upon, so 4 by 3. And plus tan inverse 1 by 7. This will continue as such, so plus tan inverse 1 by 7. Now the x into y. What it is? It will be less than 1. So you can apply tan inverse x plus tan inverse y is equal to tan inverse x plus y, and that whole lot of things. So tan inverse 4 by 3, tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus x y. So this whole thing. So this is what? Tan inverse, and then see, you can write it. You take the LCM 21, 4, 3, 7, 4, 28 plus 7, 3 upon what is 21 again here, and 21 minus how much? 4. So this is 21, 21 cancels, and it is nothing but tan inverse 28, 29, 30, 31, and this is 21 minus 4 is 17 upon 17, and this is the right hand side. So there is hardly anything difficult in it. We can take the question from miscellaneous, if you allow me. Or any questions if you. Okay, let me take question here. question number, let me take, okay, 7. 7. What is? Write the following in the simplest form. Question number 7. It says tan inverse and under root 1 minus cos x upon 1 plus cos x. Okay, so what it is? See, or if you are good in trigonometry, you can do it. You have to simplify it. So somehow this thing should come within the tan. It should become tan of something. So best way is what? Tan inverse. So it is nothing but 1 minus cos x. 1 you remove. So cos x 1 minus 2 sin square x. So 1 minus 1 minus 2 sin square x by 2. And this is your 1 plus 2 cos square x by 2 minus 1. 1 goes, 1 goes here. And 2 goes. So what you are effectively getting is tan inverse and then sin square, and then you have a root sign as well. You have a root sign. So 2 sin square root of what sin square? This is sin cos is tan square x by 2. So it is x by 2. That's all. So you have simplified. You have got this result. So see, there is hardly anything difficult. You can do it very easily. Now, 8th question again. See, it is what? Tan inverse cos x minus sin x upon cos x plus sin x plus sin x. This is what? X is less than pi. X is less than pi. This has been given. So what you need to do is same thing. Here, you simply calculate this thing, express it in terms of tangent theta, and you will get the result. So cos x minus sin x upon cos x plus, oh, very simple. What you do? You divide throughout with cos x. So what you will get? 1 minus sin x, cos x divided by cos x will give you 1, sin x upon cos x will give you 10x, and this is what? 1 plus tan x. Okay, and this is what? Tan inverse, okay, 1 minus it is. So tan inverse 1 you can always write, okay, this will be the product of this thing, fine it is. Tan inverse 1 minus tan inverse x, because see tan inverse x, tan inverse x minus tan inverse y is what? Tan inverse x minus y. So 1 minus, no, wait, hold on. Tan inverse x1 minus x, no, just a minute. What it is? 1 by tan inverse. Okay, so this whole thing can't be right. Tan inverse tan of, yes, this thing can be written as tan of 1 minus x. Okay, tan of 1 minus x, no, it will be 1. So it is tangent pi by 4. Okay, better write it like this. And then this bracket. Good. See, this is presented. Now tan inverse, because see, if you open it, what you will get? If tan a minus b is what? Tangent pi by 4, that is 1 minus tan x upon 1 plus tangent pi by 4 into tan x. And this is nothing but 1 minus tan x upon 1 plus tangent pi by 4 is 1 and tan x. So at place of this whole thing, what you can write? Tan pi by 4 minus x. So tan inverse tan is what? So eventually what you will get is pi by 4 minus x. So that would be the answer. That would be the answer. So this is how you can do this question. Let me check it if there is any other question here. Okay, 9th, 10th, again simple. Question number 10, if you want, we can take it up because it is nothing, simple. Question 10 I am doing, okay. It is tangent 3 theta formula, nothing beyond it. Tan inverse, it is 3ax square x minus x cube upon a cube minus 3x square. A cube minus 3ax square. And minus a by root 3 is less than x is less than a by root 3. So there is hardly anything difficult in it. What you need to do is simply you put x is equal to a tan theta. So what this thing will become? It will become put x is equal to in 1. So what you think? It is tan inverse 3a square x is a tangent theta, so it will become a cube tangent theta minus a cube tan cube theta upon a cube is a cube minus 3a and x square. So a square into a is a cube and x square is tan square theta. So this would be, so this is nothing but tan inverse. A cube you take common, it will cancel throughout. By taking common, you will get 3 tangent theta minus tan cube theta upon this whole 1 minus 3 tan square theta. So this is nothing but tan inverse, this is tangent 3 theta. You must have read it in the trigonometry, so you will give theta, and theta is what? X upon a tan inverse. Tan inverse x by a. So that's the answer. This is how you will take up the questions. Let us now take few other questions here. Let me, okay, take question number, okay, 11, let me take it. Let me take it 11th question. But see, these questions, as a matter of fact, you should have tried on your own. You shouldn't have tried on your own because they are simple questions. And once you do it on your own without taking the help of anyone, then see, you will find that you will learn a lot also. Then you will learn also a lot. Yes. Any question you may take in. I will take from 11 to 15, I will be taking 2 questions, any 2, 11, okay. Tan inverse, okay. Within bracket they write 2 cos, and then again a small bracket, 2 sin inverse 1 by 2. This bracket and this bracket. Simple. So what is? Let's calculate from inside. Tan inverse, let us write 2 cos. And let us, in this innermost bracket, let us simplify it. What is sin inverse 1 by 2? Sin 30. Sin 30 is what? Pi by 6. Sin pi by 6 is 1 by 2. So it is pi by 6. So it is at the bracket close. So you are basically tan inverse 2 cos pi by 3. What is pi by 3? Cos 60. Cos 60 is how much? It is again 1 by 2. So it is tan inverse 2 into cos 60. Cos 60 is 1 by 2. Okay, so it is tan inverse 1 and tan inverse 1, everybody knows it is pi by 4. I think that was the result which you wanted to prove. So that would be the answer. See, simple questions, there is not anything here. Okay, let me take another question here. Tan 1 by 2, this one. Okay, question number 13, let me take it. Question number 12 is one line question. Tan inverse A plus cot inverse A is pi by 2. So cot pi by 2, value of cot pi by 2 is what? Tangent pi by 2 is undefined, isn't it? And it will be cot will be then what? Cot is cos pi by 2 upon sin pi by 2. So 0, that's the answer. 13th question. Oral questions here. 13th question, let us see. Tan 1 by 2. Tan 1 by 2 within brackets sin inverse 2x upon 1 plus x square, 1 plus x square plus cos inverse 1 minus y square upon 1 plus y. see, simple. Oh, one line of question. You have already done the properties. Sine inverse 2x upon 1 plus x square. At place of this, what you can write? Simple. It is 2 tan inverse x. 2 tan inverse x. And this is likewise 2 tan inverse y. These are the properties. Please try to recollect. We have even given the proof of this. These properties have been given even in your book also. So hardly anything difficult there is. So here this becomes what? Tan, and then tan inverse x plus tan inverse y. These two goes, and then tan of tan inverse x plus tan inverse y is nothing but tan inverse x plus y upon 1 minus xy, and then tan inverse will give you the same thing, x minus 1 x minus, because they are inverse of each other. So that would be the answer. That would be the answer. So that was your question number 13. Okay, now we proceed further. Yes. So rest all see, I don't think that there is any problem in doing the question. Let me take a 15th if you want. 15 question 15. What it has to say? Tan inverse x minus 1 upon x minus 2 plus tan inverse this thing x plus 1 upon x plus 2 x plus 1 upon x plus 2 is equal to pi by 4 is equal to pi by 4. Okay, simple. So here see, this is 15 question. Here is equal to pi by 4, then find the value of x. Okay. Find the value of x, you have to find it out. So what you will do? Tan inverse x plus tan inverse y is equal to this thing. This is less than x, y is less than 1. So here you can invoke the formula. So it will be tan inverse x plus y. X plus y means what? X minus 1, x minus 2 plus x plus 1 upon x plus 2, and then 1 minus xy. 1 minus x minus 1 upon x minus 2, and this is x plus 1 upon x plus 2. This whole lot. Let us simplify this thing. So this simplification will give me what here? It is tan inverse, yes, it is x plus 1, x plus 2. It is coming on your screen or not? See one gentleman. Just hold on. You see, this much of thing I will do it over here. Okay, so it is what? Tan inverse. Now you will add them. So what you will, on addition, what you will get here? You will x minus 2, x plus 2, and here you will get x minus 1 into x plus 2 and plus x plus 1 into x minus 2. And then upon what else is x minus 2, x plus 2, and this will be your x plus 2, 1 is x plus 2, x minus 2, minus x minus 1, x minus 1, x plus 1 is x squared minus 1, okay. So this whole thing. Let us simplify this thing. So what it gives us, it is tan inverse. Let us simplify this lot here. This numerator will cancel, so nothing to worry here. X minus 1 into x, so it is x square plus 2x minus x minus 2 plus this bracket is x square minus 2x, okay, plus x minus 2. okay, and upon what? It is your x square, x plus 2x square minus 4 minus x square plus 1. So x square will cancel and here minus 4 will fetch you how much? X square minus 2, isn't it? It was x square minus 4, okay, minus, so this is x square minus 4 minus x square minus 1, x square cancel minus 4 and plus 1, so minus 3. So it will be minus 3 here and tan inverse. Now here what gets x square will cancel with x, no, it will be giving you 2x square. It is plus sign in between, no, minus sign here. So plus sign in the numerator, okay. And this 2x goes, this minus x with plus x, this also goes. So what you are getting is tan inverse, and this x square is 2x square, and minus 2 and minus 2 minus 4 upon minus 3. This is what you are getting here. So no issue, and this has been given to be pi by 4, and pi by 4 is nothing but tan in, okay, so it is pi by 4, so this thing implies 2x square minus 4 upon minus 3, this is equal to tan pi by 4, that is 1. And so 2x square minus 4 is equal to minus 3. This 4 you take other side, 2 square will be plus 1. So x square will be how much? 1 upon 2 under root. So x will be what? Plus minus 1 upon root 2. Root 2. So that will be the answer. This way you can do it. This way you can do it. Now let me take problems from the miscellaneous exercise here. Because there is hardly anything which you can't do it. You know. In fact, these problems you can do on your own, and we need not to, because unless until, see, you should take the initiative. So I will take few problems from the miscellaneous, and then we will wind up this chapter. Yes, miscellaneous. Question number, okay, any question, prove that. From question, see, first two are very simple. Find the value of the following, for example, suppose they say, right, cos inverse. Question 1 itself I will take. See, find the value of the following, cos inverse and cos of 13 pi by 6. 13 pi by 6. Now see, immediately you can't write like this, that this will be 13 pi by 6, because we had to ensure that whether 13 pi by 6 is lying between 0 and pi or not. Obviously it is not lying, it is even going beyond 2 pi. So first of all, see, we had to be careful. We had to, because inverse of course is fine, but this thing should come within the principal branch. And what is the principal branch of course? Inverse, cos, its principal branch will be between 0 and pi. So let us bring this between 0 and pi. So cos 13 pi by 6. So see, cos 13 pi by 6, let us see how we can write it so that it is cos. First see what you can do. You better write it is 2 pi plus 6 to the 12 plus pi by 6. Yes, see, it is better always. At cos 2 pi plus something is nothing, but it is always cos pi by 6. So it is always better to write like this. So it is cos inverse cos of pi by cos of pi by 6. Isn't it? Now see, it is pi by 6. So that thing only you have to ensure you have to remain within the respective principal branches. That's all. Okay. This was question number 1. Similarly, question number 2, you can do it on your own. Now, question number 3 to 8, they are of the same nature. Let me take any two of them if you feel. 7th question, let me take it. 7th question, question number 7. Okay, what it has to say, show that tan inverse 63 by 16 is equal to how much? Sine inverse 5 by 13, sine inverse 5 by 13 plus cos inverse 3 by 5, cos inverse 3 by 5. So what you can do here? See, sine inverse is given 5 by 13, okay, and so point is somehow we have to convert these values in terms of tan. So how we can do it? Okay, simple. Let sine inverse 5 by 13 is equal to theta 1. So what it implies? That sine theta 1 is equal to 5 by 13. So cos sine theta 1, what does it mean? You have this triangle here. This is theta 1. Sine theta is, so it is 5, this is 13, obviously this is 12. So cos theta 1 will be how much? It will be your, it will be 13 by 12 by 13, and tangent theta 1 will be equal to your how much? It will be 5 by tan sin theta cos theta, sine upon cos, so 5 by 12. Likewise, see what you do is you put cos inverse 3 by 5 is equal to theta 2, and so cos theta 2 is equal to 3 by 5. So again you can construct a triangle here. See, this is theta 2 and cos is 3 by 5, so this is obviously 4. So sin theta 2 will be equal to how much? It will be cos theta is 3, so it is 4. So sin theta 2 will be what? 4 by 5, isn't it? And then tangent theta 2 will be what? It will be 4 by 3. Sin theta 2 upon cos theta 2. So now see, point is theta 1 will be equal to what? Tan inverse 5 by 12. Now this is theta 1. So at place of this, what you can write? Tan inverse 5 by 12, and likewise tangent theta 2 is this thing. So theta 2 is about tan inverse. So plus tan inverse 4 by 3. 4 by 3. Okay, do right. Yes, and cos inverse 3 by 5 is equal to theta. Okay, no issues. Now, what do you need to do? Once you have done it, then see this much of thing you have done. Then see tan inverse x plus tan inverse y. Now xy is what? It is less than 1 because 20 upon 36. So that is less than 1. Xy is less than 1. You can apply tan inverse. This will become tan inverse x by x plus y, 5 by 12 plus 4 by how much? 3, and 1 minus 5 by 12 into 4 by 3. So what it is nothing but tan inverse. You can do it. These are very simple questions. 36 is the LCM, and then 315 plus 3, 12, 4, 48 here upon what else here is 36 will be the LCM here, and then 36 minus 20. So 36 goes, it is tan inverse how much? 48, 15, 8, 9, 10, 30, 63 upon 6, 36 minus 20, 16. And this is what your left hand side is. So there is hardly anything difficult herein. You can try these questions, you can do it. Even in the miscellaneous also, they are very simple questions. There is nothing to be worried about. So, and see next time, I have two options to take this next chapter, determinants and probability. Already Bhavya has done it. We can start up with the continuity and differentiability. Okay, we will do it because it is always better to proceed in the sequence. So from next time I will take continuity and differentiability. But here and again, see, I would like to enlighten you that this entire problems of continuity and differentiability, they do lie wherein in their basic principle. They will be, their foundation is limits. So see, I will be going somewhat away and to explain you the concept of the limit, and then we can come to the topic, because limits have been taught to you in your class 11th, I know, but then we will further like to refresh you on the important theorems, because once you know all these things, then of course derivative will come handy, and once you know the derivative, then see, have rest all the things in your class 12 will be too simple for you to do it. So now let me take few more questions of the miscellaneous exercise here. Which one you want me to take? I can take it. Yeah, question 8. Okay, let us take it. It is nothing. Tan inverse 1 by 5 plus tan inverse 1 by 7 plus tan inverse 1 by 3 and plus tan inverse 1 by 8. Plus tan inverse 1 by 8 is equal to 1 by 4. You have to prove it. So see, you know tan inverse x plus y. See here, x into y is what, 1 upon 35 less than 1. Here it is also 1 upon 24 less than 1. So you can invoke your those formulas. So tan inverse x plus y 1 by 5 plus 1 by 7 upon what else? A big bracket you can put it upon 1 minus 5 into 1 by 7. And then here again do the same thing, tan inverse 1 by 3 plus 1 by 8 upon 1 minus 1 by 3 into 1 by 8. Okay, so it is what tan inverse, just simply LCM is 35, 7 plus 5 upon 1 minus how much? 1 upon 35. So take the LCM 35 here. So it will be 35 minus 1 on in the numerator here. So it is on 35 will go, and we will keep the rest of the things here. So tan inverse, nothing, see, 24 is the LCM 8 plus 3, and here it is what you will get here in the numerator will be here 24 minus 1 upon 24. So this whole thing here. So eventually what you will get, tan inverse 7 12 upon how much? 35 minus 1, 34 plus tan inverse 8, 9, 10, 11 upon 23. 24 will cancel. Again see, do the same thing. Tan inverse how much? It will be 12 upon 34 plus 11 upon 23, and then 1 minus, big bracket you can put it, 1 minus how much? 12 by 34 into 11 by 23, this way. Simplify it, you will get the answer. I don't think you will encounter any difficulty. So what it is, tan inverse LCM will be what? 34 into 23, and then 12 into how much? 23 plus 11 into 34 upon, this is 23, and upon what? 34 into 23, 34 into 23 minus 11 into 12. So this thing, this whole will cancel, and what you will get is tan inverse. Okay. Now, please see, you simplify this thing and you will get the answer. I think there is hardly any problem. This whole, you multiply 12 into 23, how much it is? 12 into 23, 3 to 6, 3, 1, 3, 2, 4, 1. It is 6, 4, 3, 7, 176. So 12 into 11 into 34, how much it is? 11 into 34, 4, 4, 3, 3, so 4, 3, 7, 3. Add 374 here, 6, 4, 10, 7, 15, 3, 4, 5. Yes, I think it's okay. So numerator will fetch you what? 550. And let us see what denominator has to say. 34 into 24. 34 into 24 is what? 4, 4, 16, 14, 12, 13, 2, 4, 8, 2, 3, 6. So 6, 8, 9, 10, 11, 6, 7, 8. And minus how much? 11 into 12. 11, 12 on the 12. 11, 12 is what? 2, 2, 1, 1, 1, 3, 1. So 1, 3, 1, let us subtract. So here, 11 into 12. Okay, you subtract it. So what you will get here? 6 minus 11 into 12. 11 into 12. Okay. What do we get? 12. It is 12, 34, 11, 23, 12, 54, 11, 23. Yes, 12 into 11. 2, 2, 2, 2, 1, 1, 2, 3, 1. 131. And this is 34 into 24. 34, 4, 16, 40, 13 and 2, 4, 8, 2, 3, 6, 6 and 8. What is this? 33, 8, 9, 10, 11, 1, 6, 7, 131. Okay. So it is to be subtracted. Subtracted, so what is it? 5 and 6, 1, 5, 11, 8 and 7, 1, 685 you are getting here. So ultimately what you are getting? Tan inverse 550 upon this thing. And what do you have to show? It is pi by 4. Tangent pi by 4. It should be tan inverse. It should be 1. They should come together. Let us do it once again. Let us do once again. This entire calculation. Somewhere we have done wrong. Is tan inverse 1 by 5 plus tan inverse 1 by 7 plus tan inverse 1 by 3 plus tan inverse 1 by 8. Okay. Tan inverse 1 by 8. Simple. It will be tan inverse, yes, 1 by 5 plus 1 by 7. Tan inverse x plus tan inverse x plus 5, 1 minus 1 by 5 into 1 by 7. Okay, no issues. Plus, likewise here, tan inverse, it will be 1 by 3 plus 1 by 8 upon 1 minus 1 by 3 into 1 by 8. So, it will be how much? 7, 5, 35. So, it will be, I'm tan inverse 7 plus 5, 7, 3, 10, 10, 11, 12. So, it will be 12 upon what I'm just simply quickly doing is 7, 5, 35, 35, 35 will tell them 35 minus 1, so 34 plus tan inverse, what it will fetch me, 8, 9, 10, 11 here, 11 upon 8 into 3, 8, 3, 24 minus 1, 23, tan inverse this thing. Now this thing will fetch me what? Tan inverse 12 upon 34 plus 11 upon 23, 1 minus 12 upon 34 into 11 upon 23. Okay. Let us calculate this thing. Let us see what it is giving me. Tan inverse is 34 into 23 and then 12 into 23 plus 11 into 34 upon what you will get 34 into 23 minus 12 into 11 upon 34 into 23. This will cancel. Eventually you will be left with this thing. Let us see what is this 34 into 23. 3, 4, 12, 1. 3, 4, 12, 1. 3, 3, 9, 1, 10. 2, 4, 8, 2, 6. So this is 2, 8, 7. And 34 into 23. Okay. And then 12 into 11 is how much? 1, 2, 1, 1, 2, 1. So 2, 3, 1. So let me subtract it. 1, 3, 2. It is 0, 5, 7, 6, 5, 0 we are getting here. I think what we are getting. So it is tan inverse, yes, upon 6, 5, 0 is the denominator. Let me, 12 into 23 is what? 23 into 12. 3, 2, 6, 2, 2, 4. 1, 3, 1, 2, 6, 4, 3, 7, 2, 76 plus 11 into 34. 34 is 11. 1, 4, 1, 3, 4, 3, 4, 7, 3. 374, let me add it. 6, 4, 10, 50, 3, 650 you are getting both ways, yes. So 650 upon 650 you are getting. So it is tan inverse 1 and this is nothing but 5 by 4. So you can do it. You can do it. See, simple. He will encounter no difficulty there, isn't it? So I stop here. with the hope that you will do the remaining questions. They are almost very simple. So today I end up a bit earlier, and with the hope that you will try the remaining questions. Okay, thank you. Bhavi sir? Sir, should I need to post this video? Because solutions, solution you can post from somewhere. है ना? Even that NCERT solutions are there at CBSE site. So next day we will take up this next chapter. Okay, thank you.